In this video, we're going to focus on graphing exponential functions. This includes functions with the base e, but we'll talk more about that later in another video. For now, let's start with a simple exponential function. Suppose y is equal to 3 raised to the x power. How can we graph this function? What's the best way to approach it? The best thing to do is to make a table, and you want to plug in good x values. Personally, I like to choose 0 and 1. Before we do that, let's identify the horizontal asymptote. This function has a horizontal asymptote along the x-axis, which means the equation of the asymptote is y equals 0. If you ever see a constant like +2 or -1 added outside the exponential, that tells you the asymptote will shift. For example, +2 would move the asymptote up 2 units, -1 would move it down 1 unit. But if you don't see any constant, then the asymptote stays at y equals 0. Now let's plug in our x values. When x is 0, 3 raised to the 0 power equals 1. Any number raised to the 0 power is 1. When x is 1, 3 raised to the first power is 3. So the points we get are 0, 1, and 1, 3. To graph the function, start at the x-axis, which is the horizontal asymptote, and connect the curve through those 2 points. That gives us the graph of the function. Now let's talk about the domain and range. The domain represents all possible x values the function can have. For exponential functions, the domain is always -infinity to +infinity. There are no restrictions on x. The range is y greater than 0. Now let's examine another function. Suppose y equals 2 raised to the quantity x plus 1 minus 5. The -5 moves the graph down, so the horizontal asymptote is y equals -5. The x plus 1 moves the graph to the left. To find the x values, we set x plus 1 equal to 0. Solving gives x equals -1. Now we make a table. We start with x equals -1. 2 raised to the power of the quantity -1 plus 1 minus 5 is equal to 2 raised to 0 minus 5, which gives 1 minus 5 equals -4. Next, we choose x equals 0. 2 raised to the power of the quantity 0 plus 1 minus 5 is equal to 2 raised to the first power minus 5, which gives 2 minus 5 equals -3. To graph the function, draw the horizontal asymptote at y equals -5. Plot the points -1, -4, and 0, -3. Start near the asymptote and curve upward through the points. The domain is -infinity to infinity, and the range is y greater than -5. Now let's look at a function with the base e. Suppose y equals e raised to the x power minus 1. E is equal to 2.7. Now let's make a table. We choose x equals 0 and x equals 1. We start with x equals 0. E raised to the power of 0 minus 1 equals 1 minus 1, which equals 0. Next, we choose x equals 1. E raised to the power of 1 minus 1 is about 2.7 minus 1, which is about 1.7. Let's find the horizontal asymptote. The -1 moves the graph down, so the horizontal asymptote is y equals -1. Now we graph the function. Draw the horizontal asymptote at y equals -1. Plot the points 0, 0, and 1, 1.7. Start near the asymptote and draw a smooth curve through the points. The domain is -infinity to infinity. The range is y greater than -1. Now let's do one last example. Suppose y equals 6 minus e raised to the quantity x minus 2. To find convenient x values, we start by setting up the equations x minus 2 equals 0 and x minus 2 equals 1. First, we solve x minus 2 equals 0. Add 2 to both sides and we find x equals 2. Next, we solve x minus 2 equals 1. Add 2 to both sides and we find x equals 3. So our convenient x values are 2 and 3. Before we substitute the values of x in the function, notice the horizontal asymptote. Because the function is 6 minus e to a power, the horizontal asymptote is y equals 6. Now when x equals 2, 2 minus 2 equals 0. E raised to the 0 power is 1. 6 minus 1 equals 5. When x equals 3, 3 minus 2 equals 1. E raised to the first power is about 2.7. 6 minus 2.7 equals about 3.3. To graph this function, first draw the horizontal asymptote at y equals 6. Then plot the points 2, 5 and 3, 3.3. Starting near the asymptote, sketch the curve downward through the points. The domain is all real numbers, from -infinity to infinity. The range is y less than 6.